Okay, hi everyone. So today we're going to be covering questions from the chapter Forces and Pressure, okay, which is chapter 3 in Form 4. And the reason why I chose this chapter, if you take a look at the schedule, I've chosen 4 important chapters, which I think are very important. Now, if you did your analysis properly, okay, if you did the analysis of the trial papers properly, you will notice that the topic forces and pressure comes out about 7 times in paper 2. So of all the Form 4 topics, forces and pressure has quite a very big weightage, okay, in paper 2. Not so much in paper 3, okay, it's not really one of the popular experiments in paper 3, but I will still cover it anyway. But it seems to be very popular in paper 2, okay, and of all the paper 2 questions, one particular subtopic seems to be very popular amongst the trial papers, which is buoyant force, and especially with hot air balloon. So quite interestingly, so like even our trial paper also, um, we also spoke about hot air balloon. So I'm going to start off by talking about the Putrajaya paper. Okay, so the Putrajaya paper diagram 9.1 shows a hot air balloon floating stationary, yada yada. Okay, so of course we've discussed the hot air balloon question before, okay, and since we've discussed the hot air balloon question before, I won't. I mean, you can refer to the old video to find out the answer, but I'll just give you a general guide, okay, on how to do this. Okay, so what is the meaning of density? And the reason why I highlight it in yellow, because there's another paper that also asks the same question. So it's probably a good thing for us to memorize this definition. Okay, so density is mass per unit volume. Okay, that's the standard definition of density. Okay, mass per unit volume. And if you just to recap okay, density, the formula rho equals to m over v. Okay, mass over volume. Okay, so that's the definition of density. Okay, so take a look at the two situations now. Obviously, in section B, they're going to ask us to compare things lah. Okay, take a look at the density. The density is different. Okay, and then of course, take a look at the height. Of course, the height from the surface is probably different. Is there anything else that's different over there? No, doesn't seem to be anything different lah kan? Okay, so let's take a look at the comparing question now. What do they want us to compare? So, first of all, observe diagram 9.1, 9.2, compare the height of the balloon, the density of the air, and the temperature of the air outside the balloon. Oh, got temperature. Oh, okay. The temperature of the air seems to be the same, I guess. Temperature of the air outside the balloon in 9 point. Okay, never mind. Let's take a look at it first. So the first thing we're supposed to compare is the height of the balloon. So obviously for height of the balloon, 9.1 will be less than 9.2. Okay, once again, this is the lazy answer, which I don't encourage you to do lah. Okay, always do the more, the full sentence answer. Okay, density of air in 9.1 is lower than 9.2. Okay, I think you can see that over here. Okay, it's written over here, density of air here and here. So 9.1 is less than 9.2. Okay, and then the third one is temperature of the air outside the balloon. Okay, temperature of air outside the balloon, since the 9.2 is higher, okay, then obviously the 9.2, sorry, wait, the temperature of air outside the balloon. Okay, so since the balloon 9.2 is higher, means inside the balloon, uh, the, no, sorry. Since 9.2 is higher, right? Higher, obviously we know that the higher you go, the temperature outside will be much cooler. Okay, so I would say that the temperature of the air outside the balloon, outside, not inside the balloon, outside the balloon, okay, means the surrounding temperature. So the higher you go, the lower the temperature will be. Okay, yeah, the higher you go, the lower temperature will be. So in this case, will be 9.1 is bigger than 9.2. Okay. In the question got when the balloon is released. 9.1. Oh, okay. 9.1 is afternoon, 9.2 is early in the morning. Thank you very much. Okay. Um, oh, okay. So anyway, oh yeah, lah, actually that's right. 9.1 is afternoon. Okay, so fine. 9.1, the higher, the temperature is higher. Lah. Okay, temperature is higher because it's released in the afternoon, and 9.2, the temperature is lower because it's released in the morning. Okay, then after that, the same thing. After you compare, you relate the temperature of the air with the density of the air. Okay, so this would be the higher the temperature of the air, the lower the density of the air. The higher the temperature of the air, the lower the density of the air. Okay, so this one will be the temperature high, the density, the density low. Okay, and then deduce the relationship between the buoyant force and temperature. When the temperature is high, the buoyant force is low. Okay, so the temperature is high, the buoyant force is low. Okay, and always think about it lah. Okay, always remember what affects what lah. So just be very clear. Okay, although it says buoyant force first and then temperature, be very careful lah. Don't put buoyant force first. Always think about which one affects which one. Obviously, it's the temperature that will affect the buoyant force. So when the temperature increases, then the buoyant force will decrease. Okay, that's why the balloon doesn't go very high. Okay, and likewise together, same thing with the temperature and the density. Okay, notice that in this question, okay, and this seems to be the trend among a lot of papers and also in the SPM itself. Okay, the trend is that they will not necessarily no, they will put one pair correctly. See temperature and density. That means you put temperature first and then density. And then the other pair, usually they will terbalikkan. But actually, we need to think about this. Temperature must come first and then the buoyant force is affected by it. Yang mempengaruhi adalah suhu. Yang dipengaruhi adalah buoyant force. Tetapi in the question, buoyant force comes first and then temperature. Okay, so this is because this question is so simple. Compare and then relate, that's it. Okay, so there is always there seems to be the trend to purposely trap students, okay, in one of the relationships. They will terbalikkan the order just to see whether you guys are copying without brains or actually you really know your stuff. You really stop for a while, pause to think whether the whether the which one is the affecting and which one is the affected. Mana yang mempengaruhi dan mana yang dipengaruhi. So whenever you write a relationship, okay, and you will hear me say this a lot lah, always be careful. Okay, make sure the relationship makes sense. Okay, stop for a while to think. Don't just copy without brains. Okay, just because buoyant force comes first means the relationship buoyant force is first. Not necessarily. Okay, be very careful with this. Okay, diagram 9.3 shows a boy holding balloons filled with gas. Okay, explain why the balloons rise up uh, when the boy releases them. Okay, this is probably helium gas lah kan. Okay, so the first thing you have to talk about, okay, is the density of the gas is smaller than the density of air. Okay, if we were in normal class, usually I will read this very slowly lah. But because number one, this is a recording, okay, and you can watch this again if you want. You can watch the section that you missed out. So kalau kamu lambat salin, it's totally fine. But I'm just going to go through this as quick as I can. Of course, we have a lot of questions to answer. Okay, so because the density of gas is less than the density of air, so the weight, okay, the weight of the balloon is less than the buoyant force, okay, of air. Yeah, lah. The buoyant force must be higher than the weight, then the thing will float up. Okay, this is a 4-mark question. Okay, so wow, interestingly, the scheme here only gives 3 points. So the the balloon rises up due to the bigger buoyant force. If you can't see the screen, please let me know. Then I will scroll down a little bit. Okay, the buoyant balloon rises up due to the bigger buoyant force. 3 marks only, but it's okay. Well, I can't think of another. Okay, maybe the fourth mark lah. Maybe the fourth mark is you mentioned the type of gas lah. Okay, and usually, the type of gas. Okay, the gas in the balloon is possibly possibly what? The most famous type of gas yang dimasukkan dalam balloon is definitely not carbon dioxide now, people. Okay, it's probably helium. Okay, just to make sure that we have all the 4 points. In the scheme, actually, dia bagi 3 points saja. But this is a 4 mark question. And I would say that maybe the fourth mark, comes by specifically mentioning jenis gas yang ada di dalam balloon lah. Okay. Now, I have seen this question being asked, and dia terbalikkan, explain why the balloons don't rise up when the boy releases them, which happens with carbon dioxide balloons. Bila kau tiup balloon kan, it's carbon dioxide. So the balloons sink to the ground. Okay, so we just terbalikkan everything lah. Okay, the density of gas is more than the density of air. The weight of the balloon is bigger than the buoyant force of the air. So the balloon sinks due to the bigger weight. The weight is heavier than the buoyant force. Okay, and then the gas in the balloon is probably carbon dioxide. I've seen this question asked in both ways. Kenapa balloon naik dan kenapa balloon itu tenggelam. But the basic 4 points are there. Talk about the density, talk about the difference between the weight and the buoyant force, and then tell me what, apa yang menyebabkan the balloon to rise up. Okay, and then the gas in the balloon, just state the possible gases there are. Okay, now we come to the big chunk question, which is the 10-mark question. Okay, so the 10-mark question is a hot air balloon. Now, I've covered this when we were talking about the trials, so I won't really talk much about it. But this is the kehendak soalan. Oh, sorry. Sorry, I just spat into my tab. Okay, now the reason why I highlighted blue hot air balloon is because we're going to see another question which is similar but slightly different. Okay, but it's still asking the basic things. Okay, the good thing about this question, which is something that you're not going to get in SPM actually, is that they've already given you all the 5 aspects. So nice, kan? Okay, let's talk about this. Size of the balloon must be big. Okay, obviously. Material of the balloon, you can talk about any characteristic. Try not to, try not to mention the type of the material if you can. Okay, try not to mention the type of material. I know in the black book, it gives the type of material, but we try to avoid unless you got really no more points, then you talk about the type of you talk about the material itself. And usually it's in the black book, I think it's synthetic nylon. Okay, synthetic nylon is the standard material for hot air balloon because it fulfills all the this one. Okay, it is elastic. Okay, it is strong. It is low density. Okay, it is waterproof. So you can mention any one of these characteristics. Okay, you can mention any one of these characteristics is totally fine. Okay, quantity of burners must be high. Okay, or more quantity of burners. Don't mention number. Remember, don't say 2 or 3 or 4 burners. Jangan. Just say use a lot more burners. Okay, temperature of the air in the balloon must be high, which is why we have more burners. Okay, and then the time of launching, this is actually a bonus. Okay, if you refer to the first question, the time of launching should be in the early morning or in the late evening. Okay, early morning or late evening. Okay, so take a look at the black book. Okay, this one, the black book there got answers. And I highly suggest that if you're going to compile a list of things to study lah, okay, if you're going to compile a list of things to study at the very last minute. When I say last minute, it's not one day before exam. That's not last minute. Last minute is 30 minutes before the exam. That's what I mean by last minute. Like you finish paper one, kan? Okay. Paper one is usually 8:15 until 9:30. Okay, and then paper two starts at 10:30. I think so. Okay, so you have that short amount of time to study for paper two. Okay, and we call that the last minute package lah. Okay, so last minute you take out the things that you want to study for paper two, and this should be one of them, hot air balloon. I project lah, okay, I project that hot air balloon or something to do with buoyant force is a popular question for this year. Okay, saya bukan peramal lah, okay, I'm just using the data that I have and trying to guide you. Okay, maybe you should put this into your this one so that at least kamu ada focus sikit lah. You know how to focus to study. Okay, all right. Now the reason why I'm talking about hot air balloon is because sorry. Okay, the Terengganu paper, the Terengganu paper talks about buoyant force and then ask you to compare the mother duck and the duckling. Okay, we will come to that in a little while. Okay, but in the Terengganu paper is also another hot air balloon question. Okay, and this is even better, no? They ask you for hot air balloon. They give you a hot air balloon and ask you to explain the hot air balloon. Okay, explain why the hot air balloon rises up when the balloon is heated. Okay, this is the Terengganu paper. Just give me a while. Okay, so same 4 points. Okay, number one, we talk about the density. Okay, the density, where the density is this one. And then the second point, you talk about the weight of the balloon. Okay, is less, okay, than the buoyant force. Okay, and then the third point, just the same like just now lah. Okay, the same as just now. As the boy with the balloon. Okay, after you talk about the density, compare the two densities now. Which density is bigger than which density? Then talk about the weight and the buoyant force. Okay, and then the third point is the balloon rises up, okay, due to the bigger buoyant force. Okay, balloon rises up due to the bigger buoyant force. 1, 2, 3. Okay, and I think maybe as a fourth point this one you cannot say the type of gas. So ini bukan balloon biasa. Okay, the fourth point is maybe you can talk about the temperature lah. Okay, the temperature increases when the temperature in the air increases when the balloon is heated. Okay, although actually this should be point number one. Okay, this one should be point number one. Baru this point number two, number three, and number four. Okay, so slightly different than the balloon boy holding just now, but the idea is still the same. Okay, always talk about how the density is different, then talk about the weight of the balloon and the buoyant force, and then kenapa dia naik. Okay, cuma in hot air balloon, we have to talk about when the balloon is heated, you rise the temperature. Okay, this explanation is also in the black book. Okay, so you can copy this down when you answer the question, this one. Okay, I should mention this. All these sessions that we're having, you are not supposed, you should not now, okay? You should not be copying down the answers on foolscap paper. You should be just drafting out the answers as I discuss them, and then writing out your own answers on foolscap paper, and then keep them. Okay, keep them in a separate file for your study later. Okay, you can call it the hot topic file lah. Okay, if you want lah. Okay, topik-topik yang panas. Besar mungkin dia akan keluar. Besar mungkin. Okay. So I hope that you're not expecting me to give you a full this one. I'm just going to discuss, but you should sit down and do the answers yourself. If you want me to check for you, sure, send me the paper, send me your answer, and then I will check for you. Okay, that one is totally not a problem. But don't expect me to give you the full answer on during these seminars. Okay, so diagram 9.3, this is interesting. It's an interesting question, which is used as a weather balloon to carry a I don't know how to pronounce this, radio sonde. Okay, anyway, this is a radio sonde that collects data about the atmosphere. Okay, so it's a weather balloon and it rises up when it is released in the morning. Okay, so the question obviously, oh, sorry. Okay, the question obviously, it doesn't give you five aspects, not as kind as the Putrajaya paper. Lah. Okay, this paper is pretty standard. Usually they give you three and they ask you to think about it. Lah. Okay, so this one is very interesting because the question asks for a specific gas in the weather balloon. Very interesting. Okay, so and then of course the material in the balloon, the size of the balloon. Now, size of the balloon is big lah. Obviously, the balloon must be big. Okay, or bigger if you want to say bigger. Okay, but if you see, if gas is only one, because you can only say one gas. Okay, so two marks go to there, 1+1. Size of the balloon is only one, so it's also 1+1. Means you have to talk about three things in the material. So this is 3+3. You have to give me three characteristics of the material and also three explanations. Okay, which is why I say avoid mentioning the type of material unless you got really nothing else to say lah. Okay, if you remember the Putrajaya paper just now and that I show, I already gave you, look, 1, 2, 3, 4. There are 4 characteristics you can use. So avoid using the type of material unless the question asks for it. Okay, so the material you can say, is elastic, is low density, is waterproof, okay, yada yada. Okay, but the gas, okay, I want to talk about the gas now since we haven't really covered the gas. The rest of it we've covered before, so I will not mention it now. Look at the black book for the answer. Okay, the gas should either be helium, okay, or hydrogen. Okay, yeah, usually helium or hydrogen, and the reason, the apa itu explanation kami pakai. Okay, the explanation will be low density lah. Okay, low density or light. No, low density. Okay, low density is enough. So it's a low density gas, therefore it will rise up. So we use helium or hydrogen in the weather balloon. Okay, now notice this now. This question is not really hot air balloon. Okay, notice this is a normal weather balloon. It's a normal balloon. Dia bukan hot air balloon. So, because I'm afraid that if you just memorize without thinking, you will say things that are ridiculous like add more burners. Tiada kaitan dengan burner. Okay, don't use burner. Nothing to do with burner because it's a normal balloon. Okay, so notice that the difference between Putrajaya and Terengganu. Terengganu, the 4-mark question is hot air balloon. The 10-mark question is balloon. In Putrajaya, the 4-mark question is balloon, but the 10-mark question is hot air balloon. Okay, so it's a good idea for us to get a grasp on this. Okay, especially at the last minute lah. Okay, I know I said last minute usually we just prepare for exam lah. We throw physics out the window. We just prepare the exam only lah. Okay, even if you don't understand, just memorize. Okay, wow, what a terrible teacher. I shouldn't be saying this. Okay, yeah, you should understand also lah. Okay. All right, I want to go back to the duck question now. Okay, so what is the meaning of buoyant force? Okay, what is the meaning of buoyant force? Buoyant force is an upwards force, okay, due to the weight of water displaced. Okay, I just realized that my screen share is slower than my writing. Okay, but I hope that wherever you're viewing it, dia bukan stuck lah. Because when we had our class on Monday kan, one of my biggest complaints bila saya tengok saya punya video, kenapa macam stuck ni saya menulis. So I hope this is a little bit smoother. Yeah. Anyway, what is the meaning of buoyant force? Buoyant force is an upward force due to weight of water displaced. Just to recap, buoyant force dia punya kaitan adalah dengan Archimedes principle. Okay, Archimedes principle. And I should mention here that you must not spell Archimedes' name wrongly. Okay, Archimedes, Joule. Okay, these are two very famous, or Lens. Lens is also another one. Okay, Archimedes, Joule, Lens. These are people's names, and you should never spell them wrongly. Okay, because if you can remember the name and the birth date and of every single BTS member, okay, you should be able to remember the names and the correct spelling of all these scientists. Because unlike the BTS members, they are not really as legendary as the physicists. Okay, sad to say lah, not yet lah. Okay, maybe BTS will be a legend one day. But all I know is Archimedes, Joule, and Lens, and Faraday, okay, and Newton, all these people are already legends. So please, if you can remember the spelling to every single member of BTS, okay, you can remember the names of every single physicist there are. Don't have to remember my name. I'm not a legend. Okay, but please don't get Archimedes' name wrong. Archimedes especially, always orang akan salah. Okay, so please be very careful with this. Okay, compare the weight of the mother duck and her duckling. Obviously, the weight of the mother duck will be uh, the weight of, let me see. Let me call the mother M and let me call the duckling D lah. So M is more than D. Okay, the weight of the mother duck is greater than this one. So the volume of water displaced and the buoyant force acting on both of them. So the buoyant force of the mother duck will be bigger lah, since she has a bigger volume. Okay, the buoyant force will be the mother duck is bigger, okay, than the duckling. So all these are always together. When your weight is bigger, when the volume of water displaced is bigger, then you have a bigger force. Okay, bigger buoyant force. So state the relationship between the buoyant force and the volume of water. Okay, notice buoyant force comes first and then volume of water. Okay, notice the question. Buoyant force comes first and then only the volume of water. Now this is a very dangerous one, because first line in A, I said that buoyant force is a force due to the weight of the water displaced. Now, if you take a look at this relationship, obviously is volume of water must come first. Okay, the bigger the volume, the bigger the buoyant force. Okay, to make a deduction about the relationship between the buoyant force and the weight of the water displayed. Okay, so the bigger the buoyant force, the bigger the weight. Okay, of the weight of the water displaced. Yeah, buoyant force first, and then the weight of the water displaced. Because buoyant force is what causes the water to come out. Okay, so be very careful with this. Okay, I cannot stress that you should get the 5 full marks. Okay, all you have to do is just take a little while to slowly think about the relationship. Okay, this relationship very important. Okay, must get 5 full marks. Okay, this is something that I saw during your trial exams that didn't really happen, because a lot of you can get 4 out of 5, 4 out of 5, because you always forget about this relationship thing. Okay, be very careful with this. Okay, let me just check to see if there's any questions. Okay, no questions. All right, let me move on to the next question. Okay, this next question is almost the same. Okay, this is Negeri Sembilan 2020, but it talks about a whole different thing. Now, this question is very interesting because there's 2 subtopics in this question. Negeri Sembilan 2020 and another question of and another state after this. Okay, they they are asking 2 subtopics in the same section B and section C question. Okay, so hey, hold on. Okay, sorry. Let me Okay, so question 9. Okay, question 9, and this question is from Negeri Sembilan. I don't know why I didn't show this. Yeah, okay. So, yeah, this question is from Negeri Sembilan. Should be Negeri Sembilan. Okay, Negeri Sembilan. As I said before, shows two interesting things now. Okay, two interesting things. There are two topics in the same question. Okay, which is shown later. You will see in question A and B. So in this question, it talks about the ship sailing without load. Okay, and then the ship sailing with load lah. So obviously, the one with load will be, will sink more. Okay, than the one without the load. So what is the meaning of density has already been covered in the earlier question. Density is mass per unit volume. And then when you compare, okay, compare the mass of the ship. Okay, so 9.1 is less than 9.2. Volume of water displaced. Okay, since 9.2 is sinking more, okay, 9.2 will be bigger, more than 9.1 lah. Okay, for the volume. Okay, and then therefore the buoyant force 9.2 will be more than 9.1. Okay, even though the ship is sinking, okay, now this is a very important thing. People tend to think that because the buoyant force is higher, the ship is, supposed to stay afloat. But the problem is that uh, that is not the full picture, lah. Okay, 9.2, the buoyant force is bigger because there's more volume displaced. That's why it is still able to stay afloat. Okay, so be very careful with this. Okay, I would think that a lot of people will get this buoyant force wrong. A lot of people are going to say 9.1 is bigger than 9.2, which is actually not true lah. Okay, 9.2 has a bigger buoyant force because it displaces more water. There's more of the ship in the water, okay, than 9.1. Okay, state the relationship between volume of water and volume of water displaced and buoyant force. Okay, so this will be the bigger lah. Okay, the bigger the volume, the bigger the buoyant force. Okay, the good thing about this question is there's no terbalik lah. Okay, deduce the physics concept. The physics concept will be Archimedes principle. Same as just now the duck. Okay, except that in this question, they ask you to state the concept. Okay, usually they may not lah. Okay, then next question. Next question is about the wing of the aeroplane. Okay, which I will come to in a little while. I will come back to this question later when we talk about Bernoulli's principle. So notice that just now is Archimedes principle, then suddenly question B, talk about aircraft. Okay, aircraft, since there's a difference in pressure, this is talking about Bernoulli's principle. Also another famous name that selalu kena salah eja. Okay, so Bernoulli's principle, I will come back to this in a little while. Okay, but let me go to the 10-mark question first. Okay, so the 10-mark question shows a private family boat. Okay, and then there's a plimsoll line. Okay, the plimsoll line is a line where if you're going to add stuff onto the boat, you cannot cross that line. The water level must not be higher than that line. Otherwise, there's a high possibility for the boat to sink. Okay, so the plimsoll line is there as kind of a marker. Okay, sebagai satu penanda. Okay, don't make sure that no matter how much weight you add onto the boat, the boat, okay, the level of boat in the water does not cross this line. So you are required to modify the boat so that it can carry many passengers, move with high speed, at the same time provide a safer journey. Okay, and this question is so kind. They give you all 5 aspects. Wow, so nice. Okay, material used to build the body of the boat. Again, this is characteristics. Okay, so usually we say the low density lah. Okay, so low density means it's lighter. Okay, the volume of the boat should be big. Okay, because if you have a bigger volume, you can displace more water. Displace more water, you have a bigger buoyant force. So the answer will be bigger buoyant force. The distance of the plimsoll line from the surface of the sea, okay, should be big. Okay, you need to have a big distance lah. Okay, because if the this I mean if you add gun, then if the plimsoll line is still above the surface of the sea, it's good. So you need to have a bigger distance. The bigger the distance, the better. Okay, so the reason will be to avoid overloading of the boat. Okay, and that's basically the purpose of the plimsoll line. Okay, size of the propeller. This has been covered before. Okay, in a trial question, size of propeller is big. Okay, so you want to increase. Um, you want to increase the forward thrust. You want to make the boat go faster. Larger change in momentum. Okay, many answers to this. Okay, now other suitable safety features. Okay, so safety, if you want to carry passengers on the boat, so safety features can include safety belt. Okay, safety belt. You can also have a window shield, because if you're going to move very fast, I don't know if you've ever been to, like if you've ever been to Pulau Manukan or Pulau Sapit, you know that the speedboat goes very fast. And it's pretty annoying, if the wind is like hitting your face at the same time. So you want to go faster, you need to have, maybe a window shield, okay, just to protect your face, uh, or to, or or to make sure that, when you're driving, when you're driving the boat, you don't tiba-tiba kena terpeliau pula. You don't tiba-tiba, get splashed by the water lah. Okay, so that's basically the safety features. But any suitable safety features also, I think it's possible. Except for helmet lah. I don't think I've seen anybody drive a speedboat wearing a helmet lah. Okay, so try to avoid using helmet. Okay, so this is a very interesting question because it comes out again, okay, interestingly, in this question. This is, oh dear, what state is this? How come I lost all my states? This is Penang. Okay, Penang question 11. Okay, Penang question 11 also asks something to do with the plimsoll line. Okay, so diagram 11.2 shows the plimsoll line. Okay, the plimsoll line, as you can see here. So different types of waters. Okay, different types of waters will show you different levels. Okay, on where it is. Okay, so the question is a 10-mark question, I think. Yeah, this is a 10-mark question. But this is section C, so you have to choose the one that is this one. Okay, so the kehendak soalan is this. Explain the suitability of each characteristic of the loaded cargo ship. Determine the most suitable cargo ship which can carry more load at a time and is able to move quickly in water from America to the Straits of Malacca. Okay, so this is tough. If your geography is bad, then this is a bit difficult. Okay, you want to go from America, okay, which you have to go either from, depends on where you are in America lah. But I'm guessing you have to cross the Pacific Ocean to go to Southeast Asia, then the South China Sea, and then after that Straits of Malacca. Kalau kau pergi the other way around, wow, you have to go past the ocean between America and UK, which I can't remember. And then after that, the Indian Ocean, and then come to Straits of Malacca, which is like, wow. Okay, but that's the basic piece. And this is a tough paper. Okay, because if you don't know how the ship is going to go from America to Straits of Malacca, then you won't be able to choose the correct plimsoll line. Okay, which plimsoll line saya mau pakai ni? Okay, do I want to follow S? Do I want to follow T? Or yeah, which one is that lah? So let's not consider the plimsoll line first. Let's consider the volume. Okay, so we got two choices. We want the volume of the ship to be big or small. Okay, obviously we want the volume to be big. Let's do this first. Okay, do we want the density of the material used for the cargo ship? Okay, whenever you build a ship, you want to have the material to be low density. Okay, so we circle low. Okay, now the shape. Do we want it to be hydrodynamic or aerodynamic? Hydrodynamic means uh, water, aerodynamic means air. And obviously we want hydrodynamic. Okay, because yeah, I know hydrodynamic. Okay, because we're going in water. Aerodynamic is air. Aerodynamic is air. Uh, yeah, hydrodynamic is in water. Okay, but the reason is always the same lah, to decrease water resistance. Sorry, my handwriting. Okay, low density so that the boat will be lighter, large volume so that you have bigger buoyant force. Okay, this is the standard one. Now, after you've done the rest of the three, you kind of know that P is obviously the way to go. Okay, so you just have to talk about this. Now, what is this? Okay, apa ini benda ini? Okay, so the first thing is this lah. Let's say you are faced with a section C question and then like I don't know how to answer this. I don't know what is this plimsoll line. Doesn't matter, you can do the rest first. Because volume it must be small. Big, sorry. Okay, density must be low. Then the shape, obviously it's hydrodynamic. Then you see the three of the four circles are already there. So obviously P is the correct choice. So let's talk about this. Okay, so what is this? If you take a look at the S line, the S line is this one. Summer temperature seawater load line. Okay, and that's basically what you want. If you take a look at the choices, okay, you are either S or what is the other one? T. Okay, T is the other line. Okay, so you want S or T. T is the tropical seawater load line. Okay, but we want S lah. Obviously, we want S because most of our choices point towards S. Okay, so in your table, you will write this one, summer seawater load line. Hold on. Pardon me. Okay, summer seawater load line. Okay, and the reason will be so that the ship will not sink. Okay, or you can have maximum limit load on ship. Ish, kejap I seem to have lost my ability to write. Summer seawater load line. Oh, dear. Everything else is gone. Okay, never mind. So summer seawater. Okay, summer temperature seawater load line. Okay, and then the reason will be so that the ship will not sink. Okay, so as always the rest of this is there. And then obviously in your table at the bottom there, you write the best ship is P because summer seawater load line, volume is big, low density, and shape is hydrodynamic. Okay, and that's how you get the 10 marks. Okay, so two plimsoll line questions are very interesting. One has to do with the speedboat. Okay, and then of course the other one has to do with this one. Okay, so there are two states that have been asking about plimsoll. Plimsoll line has not come out for a very, very long time. Okay, so it's a good idea for us to cover this now. Okay, let's go back to the Bernoulli's principle question, okay, which talks about this. Okay, now Bernoulli's principle, let's recap. Okay, Bernoulli's principle, okay, states that when, sorry, volume and pressure, okay, the volume of fluid, okay, volume of fluid is inversely, okay, proportional to its pressure. Okay, basically, the bigger the pressure, the smaller the, sorry, not volume, velocity. Oh dear. Velocity. Okay, the bigger the pressure, sorry, the bigger the velocity, the smaller the pressure. Okay, velocity big, pressure small. Velocity small, pressure big. Okay, that's Bernoulli's principle. Velocity of fluid is inversely proportional to its pressure. Okay, so the aircraft is lifted. I'm going to change color. The aircraft is lifted um, while flying due to differences in pressure between the upper and the bottom sides of the wing. Okay, so this one actually, if this is a 4-mark question, this will be the 4th mark now. Okay, the 4th mark will be this. Okay, the differences in pressure cause the aircraft to be lifted. But that's why they ask you only 3 marks. Explain how this difference in pressure is produced. Okay, so the number one point that you have to mention, okay, number one, the shape of the aircraft wing. What is the shape of the aircraft wing called? Okay, the shape of aircraft wing is aerofoil. Okay, this is a very important word, aerofoil. Okay, um, okay, which causes velocity of air above the wing, okay, to be higher. Point number one. Okay, the shape of the wing is aerofoil. In an aerofoil, since the up there is bigger, okay, so the velocity of the air above has to be faster. Okay, point number two, uh, the higher, okay, higher velocity, pressure is lower. Okay, and then number three, pressure below wing is higher than above the wing. Okay, so below the wing is higher than above the wing, therefore the low pressure, the high pressure at the bottom akan tolak ke atas. Okay, so name the principle. This is Bernoulli's principle. Okay, now if this is a 4-mark question, the 4-mark question is this. The 4th mark is this lah. Difference in pressure causes the aircraft to be lifted, the wing to be lifted lah. Okay, but the basic three is there lah. Talk about the shape. Okay, and the shape causes the velocity above the wing to be faster, to be higher, sorry. Okay, then the second one, talk about Bernoulli's principle. The higher the velocity, the lower the pressure. So upstairs, yang di atas sana adalah low pressure. And then the third point, pressure below the wing, because di atas adalah low pressure, so below the wing is higher than above the wing. Then the 4th mark, then talk about the difference in pressure. Okay, the difference in pressure causes the wing to be lifted. Okay, and this is the basic explanation of Bernoulli's principle, which can be summarized in 4 marks. Also in your black book now, actually, it's also in your black book. Okay, now Bernoulli's principle is also asked again in this one. Okay, and also the same explanation. Okay, so diagram 11.1 shows a lady and a boy standing behind the yellow line at the railway station. Okay, so cute of this lady and this boy, like cartoon characters. Okay, so what will happen to the lady and the boy if they are standing in front of the yellow line and the train is moving fast entering the station? Okay, this one, anybody who has any experience crossing the road and bila kereta tu bergerak dengan laju bahkan, kamu akan rasa macam tertarik ke depan. You feel like you're being pushed forward. Okay, so what will happen to what will happen to the lady and the boy? Okay, so they will, oh no, one second. Okay, so they will move, actually not, they will fall, okay, they will fall forward towards the train. Okay, and then of course you have to explain your answer. So since this is the 4th mark, This is the first mark. Then the 3 marks is the same explanation again. Okay. So the first mark will be how? Same thing. Think about the aeroplane just now. Okay, the shape is aerofoil. Okay, you can't really mention about the shape, but talk about the velocity. Okay, velocity of train is high. Point number one. Okay, point number two, talk about the effect of velocity and pressure. So velocity high, pressure low. Okay, our pressure means the pressure between the lady and the boy and the train. Okay, so pressure, when we talk about treasure, pressure. Okay, the pressure between the lady and the train. Okay, the ruang di antara mereka kan the pressure is low. Okay, then the third mark, okay, the third and the final mark is the difference in pressure. Okay, difference in pressure causes a force that pushes them forward. Okay, the difference in pressure causes a force that pushes them forward. So basically, just about the same as the wing just now. Okay, except that the wing dia tarik tolak ke atas, but in terms of the pressure and this one, it pushes them forward. Okay, this question also has been asked in terms of a man standing at the side of the road. Okay, and then a car tiba-tiba lalu dengan sangat laju, and then he feels that he's going forward. Same explanation. Okay, same explanation. Okay, so please take note of that. Okay, I think we've covered this. I'm going to skip the calculation question because there's a bigger section that I want to talk about. Let's talk about this question. This is Kelantan number 2. Okay, this is Kelantan paper, question 2. Also an application of Bernoulli's principle. Okay, Bernoulli's principle. Bernoulli's principle actually got many applications. Insecticide sprayer is one. Bunsen burner is also an application of Bernoulli's principle. Okay, so name the physics principle involved in insecticide sprayer is definitely Bernoulli's principle. Okay, then after that, okay, so pick the correct answer in the box provided. Which region experiences low pressure? Okay, low pressure means high velocity. Okay, think about that. So you have to talk about which region experiences high velocity. Okay, so high velocity will be in which region? Will it be here X, or here Y, or here Z? Okay, obviously it will be in Y. Because over here the air is low. When you push over here, the air is forced out into a small space. Okay, so over here will be high velocity. High velocity, so here will be low pressure. Here low pressure, here will be high pressure. Here high pressure, so the cecair will line. Okay, so that's how the order works. Region Y got low velocity. Low velocity means, sorry, high velocity. High velocity means low pressure. Low pressure means at the liquid side, not that the pressure becomes higher, but just compared to the low pressure, okay, the pressure becomes higher. Okay, so it is able to push the liquid into the insecticide sprayer. Okay, so give one reason for your answer in 2B. Sorry, what's the question? Oh, low pressure. Why is it low pressure? Okay, because the velocity of air is high. Okay, in that region. So explain how the instrument produces a fine spray liquid. Okay, so okay, so apa itu? Where is that? The nozzle kan? Yeah, the nozzle kan? Okay, never mind. At region Y lah, you can always say. At region Y, velocity of air is high. Thus, THUS. Okay, thus low pressure. Okay, first mark. The second mark will be the higher the higher pressure in the in the in the what is this thing called? Oh my dear. In the bekas, the container. Okay, the higher pressure in the container. Okay, causes the liquid to be pushed up. Okay, to be pushed up and produces a fine spray liquid. Okay, produces a fine spray liquid. Okay, all right. So this is Bernoulli's principle in Kelantan. This one. So far we look at two important principles, Archimedes and Bernoulli, which seem to be very popular in amongst the trial papers. Okay, here's another one, which is also Bernoulli's principle. Okay, so name the cross-sectional shape of the aeroplane is aerofoil. What question is this, guys? Because I have lost my label in the beginning over here. Can somebody tell me what is this question? You know what? I can check this. I can check the chat. Perlis. This is Perlis question number 7. Okay, Perlis question number 7. I wonder. Perlis. What does it mean? Hold on. Perlis. There. Okay. So cross-sectional shape of the aeroplane is aerofoil. Okay, so diagram 7.2 shows the airflow which moving at upper region, lower region. Okay, I've explained this earlier, so I'm just going to go through this as quickly as possible because I want to talk about the experiment question. Air velocity at upper region is higher, okay, than lower region. This is standard lah. Okay, and therefore the difference in pressure and upper and lower region will produce a buoyant force. I seem to be missing this one. Okay, air pressure at upper region is lower lah. Okay, since the upper region velocity is higher, pressure is lower, therefore it produces a buoyant force. Okay, suggestions to improve the takeoff on an airplane. Not buoyant force. Did I say buoyant force? Lift force. Okay, daya angkat. Oh dear. Okay, let me scratch that out. Something is happening to Mr. Marcus today. He's being as blurred as always. Okay, lift force, daya angkat. Oh dear, this is a buoyant force. Okay, suggestions to improve the takeoff on an airplane. The wingspan should be bigger. Okay, kelebaran sayap, you need to make the wings bigger. Okay, so to increase the difference in pressure. Okay, or to increase the lifting force. Up to you lah. I don't want to can. Okay, the wing mass should be lower. Okay, so that lower means the plane can move faster lah. Okay, to increase acceleration. Okay, I want to mention this just as a passing lah. I know that when we talk about when things are lighter, when the wing mass is lower, then it is able to move faster. Okay, it's able to move faster lah. Now I want to up your game a little bit. Instead of saying supaya dia boleh bergerak dengan lebih laju, so that it can move faster, talk about this, so that the acceleration can increase. This is what we call a quality answer lah. Okay, this guy is a physics answer. This is a physics answer to increase acceleration. Because only physics people will talk about acceleration. Non-physics people will say, oh, okay, so that the plane can move faster. Okay, I'm not saying that it's wrong. It's not wrong. You can say, okay, you can say that, so that the plane will move faster. Okay, but when you say things, but when you put an answer like to increase acceleration, kan, you create an impression in the examiner. The examiner read your paper. Oh, okay, this guy probably an A plus student. Okay, so just to up your game a little bit. I'm not saying that to make the plane move faster is wrong. I'm just saying that there is always a better answer. Okay, a more chantic answer. Okay, in that case. Okay, wing material. Hold on, let me see. Are you supposed to give suggestions? Okay, so wing material should be low density. Okay, and then low density also you can say the same thing to increase acceleration. Okay, another famous answer will be the wing material should be strong. Okay, so not easily broken. Okay, or actually, low density also you can say light now. I mean, yeah, low density is always light or less mass. Wow, this is the A plus answer. Okay, the mass of the plane will be lower. Okay, so yeah, okay. Now this is probably the last subtopic I'm going to cover today, which is the pressure in liquid, and it's going to spill over into paper 3. Okay, so please be ready for this. So pressure in liquid, pressure in liquid talks about depth. Okay, depth and density of liquid both affecting the pressure in liquid. Okay, that means let's say you are a diver. Okay, if you are a diver and then you dive inside the water. Okay, this is the water. If you are here and if you are here, okay, two different pressure lah. Here is lower pressure, here is higher pressure. Because here is lower depth, okay, over here is higher depth. So the bigger the depth, the bigger the pressure. Okay, makin dalam, makin tinggi tekanan di dalam cecair. Okay, the second this one is density. Okay, the second factor that affects pressure in liquids is density. Okay, and density and depth are the only two factors that affect pressure in liquid. The type of bekas does not affect the pressure, does not affect the height. Okay, so be very careful about this. There are only two factors that affect the pressure in liquid. Okay, it's kamu punya kedalaman atau jenis cecairnya, the density of the liquid itself. Okay, that is what affects the pressure in liquid. Okay, so diagram 2.1 shows two different containers filled with the same type of liquid. That means the density is the same. Okay, same density. Same type of water lah. Okay, maybe both is Milo, maybe both is salt water. Okay, the liquid pressure at point P and point Q are the same. Okay, because the same depth. So what is the meaning of pressure in liquid? Let me see, what question is this? Perlis, no, this is not Perlis, this is Negeri Sembilan. Okay, this is Negeri Sembilan, question number 2. Negeri Sembilan, okay. Negeri Sembilan, question number 2. Okay, so pressure in liquid is pressure due to the weight of liquid on a surface of an object in the liquid. Okay, pressure due to the weight of the liquid on the surface of an object in the liquid. Okay, so lebih banyak liquid, the bigger the weight of the liquid on you, the bigger the pressure you feel. Okay, which is why the deeper you go into the water, because there's more water on you, okay, so you feel more pressure. Okay, state one factor that affects the water pressure. Okay, this density lah. Okay, calculate the water pressure. Okay, the formula for water pressure is P equals to rho Hg, but please remember to change this to meters. Okay, So the density is given, so P equals to 900 times, since this is 10 centimeters, okay, this is 10 centimeters, bahkan. So 10 centimeters change to meters. So, not, this 0.1. Okay, and G is the standard 10. Yeah, okay, so this is 900, and the unit for pressure is Pascal. Okay, so yeah, take this as a ulang kaji lah. Okay, just to remember the definition, remember the two factors that affect. Okay, and also remember the only formula that is involved in water pressure. Okay, which is P equals to H rho G, rho Hg. Fine. Okay. Now diagram 2.2 shows the water spurt when a hole is made near the base of the container. So over here, the water spurt is further. What about here? Okay, diagram 2.3 shows the water in a container replaced by liquid X, which has a higher density. Okay, so how would you see? Okay, so as I said just now, the bigger the depth, okay, the bigger the pressure. Okay, and density also the same. The bigger the density, the bigger the pressure. Take a look at the formula. P equals to rho Hg. Everything is directly proportional. P is directly proportional to density. P is also directly proportional to H, okay, to the depth. So, since this has a higher density, liquid X, when the water spurts out, do you think it will spurt out before Z or after Z? Okay, it will spurt out after Z lah, because it has a higher pressure. Okay, higher density means higher pressure means it will spurt out even further. Okay, all right. Wow, we are only at question number 20. We're only at page number 20 and only have half an hour to go. Okay, let's try to finish this. Okay, Allah, what question is this? Somebody is, that was for just now. What was for just now? Okay, this is Putrajaya question number 4. Okay, Putrajaya question number 4. Okay, so diagram container different heights x and y, water spurts out due to its different pressure. Obviously, you know that y will be much further, x will be much nearer. Okay, this is very standard. Huh? So what is the meaning of pressure? Not pressure in liquid, huh? Pressure. Pressure is force per unit area. Okay, force per unit area. This is apa itu Putrajaya kah? Yeah. Putrajaya question number 4. Force per unit area. All right. Now predict the distance of the water spurts out at holes x and y. X will be less than y. Okay. I mean, sorry, I'm giving you the lazy answer, but please write it in full sentence. The distance of water spurts out at x is lower than the distance of blah, 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 y. Okay, based on your diagram in 4b, draw the water spurts. Okay, I've already drawn, although you're supposed to draw it in 4. Oh, okay, yeah, I've already drawn it for you. Okay. Now, question D, density of water is 1000 kilograms per meter cube. Okay, this is 3 centimeters down, but this is 2 centimeters. So we know this is how much? This is 1 cm lah. Okay, so calculate the water pressure at point Z. Point Z is 2 cm. Okay, so because it's 2 cm, remember, change it to meters. Okay, so water pressure is rho Hg. Okay, rho is 1000 given in the question. Okay, H is 2 divided by 100 is 0.02. Okay, and then G is, as always, 10. Okay, don't forget now, please change to meters. Okay, if water is replaced with seawater, okay, what will happen to its pressure? And give the reason why. Seawater, and what kind of water is this originally? Normal water. Okay, So let's compare. Talk about seawater and normal water. Which one has the higher density? Okay, obviously, seawater has higher density. So higher density, the pressure will increase. Okay, because density of seawater is higher. Okay, density of seawater is higher. Yeah lah, cause normal water got nothing inside ma. Seawater got water and salt. So got yeah lah, higher density lah. Duh. Okay, this is question 11 from, sorry, which state? Question 11 from Kelantan. Okay, Kelantan, question 11. Okay, we're coming to the end. Don't worry, we're coming almost to the end. But this is the last two that is pretty big. Okay, question 11 from Kelantan also talks about pressure in liquid, but slightly different towards the end. Kita tengok dulu. Okay, so same thing. What is the meaning of pressure? Force per unit area. This one I've covered in the question before this. Okay, dan ini kita sudah lihat lah as just now. The higher the this one, sorry, the bigger the depth, the bigger the pressure. Okay, makin dalam please remember depth okay, kedalaman diukur dari surface of water, not from the bottom of the sea. Okay, kedalaman diukur dari paras air. Okay, question B. Explain why the horizontal distance of water spurting from D is shown. So explain why this one. Okay, so it's a 4-mark question, and I think I've already explained the 4 marks now. Okay, talk about the difference in the depth, talk about the difference in pressure. Okay, talk about the relationship between depth and pressure, and then talk about why Q is further. Okay, so I will leave this to you. You can answer this and show me to me your answer. I can help you to see if your answer needs to be improved. But I've already explained this before this now. Okay, question C is slightly, question C is a calculation question, which I don't want to cover today. I want to cover this. Okay, so this is a dam question, hydroelectric dam. Okay, ada kaitan dengan pressure and pressure in liquid. Okay, so let's take this into account. Pressure is this, pressure in liquid is this. Okay, so table 11.1 shows the characteristics of 4 dams, which is used to rotate the turbine to generate electricity. This question is an old question actually, but it hasn't come up for some time. Okay, quite interestingly lah. Okay, let's take a look at what we want the question. So dam that is safe, ini yang kita mau. Okay, we want to study the characteristics of the dam that is safe. So let's take a look. Height of the retaining wall. Do we want it to be low or high? Obviously, we want the retaining wall to be high. Okay, so that so that the depth will be bigger. Okay, depth will be bigger, or it can it can contain more water. What's the point of a dam? If the wall is so low, then you cannot simpan banyak air. Then when there's a water crisis, oh no, there's no water supply. Okay, type of material. Do we want wood or concrete? We obviously want concrete lah. Okay, unless you're a beaver yang build dams using wood. Okay, no. We want to build big dams. Okay, big dams. So we use concrete. Thickness of the wall at the bottom. Okay, thickness of the wall at the bottom. The side. You know this. Okay, dams. If you look at the side. Okay, if you look from the side, this is how the thickness will be lah. Okay, what you don't see is this lah. Okay, tapi sebenarnya the wall of the dam, okay, is slanted. So you want the thickness to be bigger at the bottom. Okay. Finally, the shape of the wall. Is it not curved with even surface or curved with even surface? Or curved with uneven surface? Which one? Not curved with even surface, curved with even surface, or curved with uneven surface? Interesting question. Okay, actually, the correct choice lah. Okay, according to this, and I kind of agree, The correct answer is this, curve with uneven surface. Ha! Okay, the correct answer is this, curve with uneven surface. Now, the reason for this, okay, is this law. Okay, to produce uneven reflection of water wave. Okay, this is one, to produce uneven reflection of water waves, or to slow down the erosion of the wall. If, okay, curve is definite lah. Okay, curve is definite. Okay, we want the wall, to be curved lah. Okay, so sorry, if you take a look, if the top view, okay, kalau di atas ini, we want this one to be curved. We don't want it to be straight. Okay, because straight means it's reflecting very fast. If you have, and we know that, straight is harder, is when you reflect, then the effect is bigger. Or when you curve, everything focuses on one point. Then after that, it disperses. So it's better. But why is it that we want uneven and not even? Because the more even your surface, the better reflection there will be. And the better reflection there will be, means you're going to have, the water come in and then reflected back and then berlanggar dengan the rest of the water. We want to reduce that effect. So we have uneven surface. Okay, so that, when the reflection comes back, it's like, macam tu lah. Sorry. Yeah. Okay, so the uneven surface reduces the effect of the reflection. Okay, so that it doesn't fully come back to you. Okay, dia macam kena kacau at the wall. Okay, and also to avoid, the erosion of the wall, because when you have too much going on an even surface, okay, there is a possibility for it to break faster. Okay, if it is even. Okay, and actually, if you think about it, sorry, not if you think about it. So this is the problem. L, nampaknya L yang memenuhi ini bahkan. Okay, L yang memenuhi ini. But it only fulfills 3 out of the 4. So what are you going to do? Okay, obviously J tak boleh lah, tak boleh langsung tiada. And then K also tak boleh because it's wood, we don't want wood. Okay, M also cannot. We have to choose L. But L only fulfills the 3. Okay, so how would you answer your 10-mark question? Because we're so used to a perfect world, kan? Mesti keempat-empat itu kita circle. This has happened before in SPM. 3 of the 4 yang memenuhi. You still have to choose L. You memang no choice. You still have to choose L. But what about the reason? Okay. Now, when you write the reason, you still write all the 4 reasons for L. Don't miss out. You still have to write 4. 4 for 1 4. Okay, you still have to write this reason, walaupun, okay, although this reason this is the one that we want, a curve with uneven surface. Okay, it doesn't matter. If you have chosen L, just write L's characteristics, okay, inside your answer. This has happened before, and a lot of students are there like, die la, only 3 out of the 4. What am I going to do? And then they panic. Okay, don't need to panic lah. It's very obvious that we want L. Okay, it's just how to write the reason, right? Okay, write it all according to L. Okay, although L doesn't fulfill this curve with uneven surface, we still write L in here. Okay, so sometimes that's how, sometimes that's how life is like, You want everything to be perfect, All the check marks are tick, 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 tick. But sometimes life throws you a curveball, you can't get all those ticks. Sometimes one of the ticks may be missing. It's okay. Go ahead. Make the best choice with what you have. And definitely you'll be okay one. Okay. Wow. Motivation for the day. Okay. I want to talk about paper 3 question. Okay. This is Kelantan paper 3. Okay. This is Kelantan paper 3 question 3. Okay, please correct me if I'm wrong, but I think it is Kelantan. And actually, the Pahang question also asks the same thing. Okay, the Pahang question also asks the same thing. Cuma dia punya perbezaan ini adalah sedikit lah. So in the Kelantan paper, the manipulated variable is depth. The responding variable is pressure. Okay, and the constant variable is density. But in the Pahang paper, which you don't have, okay, Pahang paper don't have, because we haven't found it yet, but somebody has analyzed it. The Pahang paper, the manipulated variable is density. Okay, the responding variable is also the same, pressure. Okay, and the constant variable is depth. So I want you to learn these two experiments. Okay, as a beginning for this particular topic, learn up this experiment. Okay, unfortunately, there is no sample in your this one. Okay, in the SBT book. So I'm going to discuss the experiment here. But I want you to know what this one is. And the reason why I want to do this is because there is a trap in this question. Okay, now take a look at this. Whenever we think of bubbles, okay, whenever we think of bubbles, and then the bubbles semakin lama semakin menjadi besar, bahkan we always think of Boyle's law. Okay, but Boyle's law is in chapter 4, heat. Boyle's law states that when the pressure increases, the volume decreases. Okay, this is Boyle's law, which is also the same situation as this, you know. Oh. But as I said earlier, this situation is actually chapter 3, pressure in the depth of the liquid. But it is also the same situation as Boyle's law. Okay, and this one, I have to give credit to the person who made this question. It's a very smart question. It is designed to trap students. Okay, because when people see this, automatically they will think Boyle's law. Even when I saw this question, I first thought, doesn't this look like Boyle's law because of the bubble, bubble, bubble? Okay, but how did I know that it was pressure in liquid? Because of the apparatus given. Look at the apparatus given. The apparatus given, apa ini? Oh, okay. Apparatus given is a Tissot funnel and manometer. Okay, now if you've never seen a Tissot funnel and manometer, yeah, I don't think I've ever showed you. In a while, I will show you. Okay, this is how I know that, oh, this is a pressure in liquid question. It is not a Boyle's law question. If it is Boyle's law, okay, I'm going to write it down for you in case Boyle's law comes out. Okay, if it is Boyle's law, your apparatus will have to have a Bourdon gauge. Okay, this is a must. Bourdon gauge must be in this one. Syringe is also another one. Okay, bicagari lah. Okay, a big this one. Or piston. Piston pun saya pernah nampak. Okay, ombok dalam bahasa Melayu is ombok. Now, if this is a Boyle's law question, then the apparatus that they will supply for you is Bourdon gauge and syringe. Okay, that's definite. But because over here they check up Tissot funnel and manometer, and you must use these two. You cannot use, you cannot use any other thing. I mean, these two must be included in your apparatus. Okay, so Tissot funnel and manometer shows us that it is pressure in liquid. That means our manipulated variable, okay, in this question, it will be the bigger the depth, the bigger the pressure. Okay, and then kalau paham, the bigger the density, the bigger the pressure. Okay, so please take note of this because it is a very good question and I want to show it to you. I want to put it on YouTube so everybody can learn this. Okay, don't be trapped now by the situation. Read the question properly, take a look at the apparatus and what they supply. If they supply a Tissot funnel, it is a pressure in liquid question. Okay, so this is how the experiment is now. Oh dear, I'm not sure if I can I make it? Yeah. Okay, so this is how the experiment is. Kalau dia adalah liquid pressure. Okay, so pressure depends on density. Density, the bigger the density, the bigger the, okay, this one, the difference of height in manometer. This is our operational definition. You can actually write the bigger the density, sorry, this is depth. Sorry. I should be showing you the depth question. This is the depth question. My mistake. Okay, pressure in liquid depends on depth. Okay, the bigger the depth, the bigger the pressure. You can also write pressure over here. Okay, you don't have to write this, but you have to operationally define pressure in liquid, is represented by difference of height in manometer. Okay, then the aim and everything. Okay, so this is how the apparatus looks like now. Okay, this is how the apparatus is. Now, this is a thistle funnel. Okay, a thistle funnel is like a glass rod over here, and then there's a small bowl over here like this. Okay, and then what we do is we put a thin rubber sheet over here. Okay, kita letak satu, usually it's a balloon lah, can also be a balloon. Okay, you cover the mouth of the bowl, okay, with a balloon. Okay, and then you push this into the water. When you push this deeper into the water, okay, there is going to be bigger pressure. Okay, and the pressure will push this salt water up to a certain level. So there's a difference in height over here. This difference in height represents the pressure in liquid. Okay, so for this particular question, you need to add another statement down there and write down the operational definition. Okay, write down the operational definition. You know what? I'm going to move my face so that those of you who want to, those of you who want to screenshot this for your this one, you can. Okay. Then the same thing, we've discussed experiment before, so I'm not going to read this one. So you set a different depth, 0.5, 1.0, 1.5, 2.0, 2.5. You can set it up to 5. Then, of course, don't forget the table and then the analysis of the graph. Okay, I just want to show you this experiment. I'll take a screenshot of it, but be very careful. In the liquid pressure question, there is no way we can measure pressure because we don't have a Bourdon gauge. Okay, so we have to operationally define. Okay, we have to wakilkan, represent the pressure in liquid by using the difference in height in manometer. Okay, so take some time to read through this experiment, try to understand it as much as you can. Maybe when we go back to school, I may just show you the experiment, okay, so that you get an idea of how it is done. Okay, or I may just share with you videos. Yeah, you know what? I'll share with you videos so that you see how the experiment is done, so that you can get a better picture of it. Okay. Now, this is the Kelantan question, which is the manipulated variable is depth, the responding variable is difference in height, okay, or pressure lah. Okay, this one kalau ini kamu tulis pressure pun tiada masalah. As long as you write this operational definition. You must write the operational definition. Okay, otherwise everything will not work. Okay, but the Pahang question, if you remember just now I said, the Pahang question is density and pressure. So the setup is the same, actually. The setup is the same. Take a look at this. The setup is the same, except that instead of pushing this one down, okay, you set it at 20 cm. And then you change the water. Okay, the water changes. In the depth experiment, the water is the same. Okay, same type of water. Okay, but the depth changes. Okay, you push the thing lower and lower and lower and lower. Okay, and take the reading lah. But in the density experiment, you change the water. Okay, so if you take a look at this number 4, the experiment is repeated by using different density of salt water, which is 1, 1.5, 2, and 2.5. Okay, but you always push to the same depth. Okay, always push to 20 cm. Okay, to be safe, 20 cm. Don't put 1 cm. 1 cm very difficult to read. Okay, push it a lot inside. 20 cm, 30 cm, depending on how big your measuring cylinder is. Okay, but you change the density of the salt water. Okay, so this is 2 experiments using the same apparatus. Just that you have to tweak. Kamu kena ubah sedikit dia punya langkah kerja saja. Okay, so I'm actually providing you two experiments. I hope that you can prepare both experiments. Okay, just write it out, both experiments according to the 12 mark format, okay, that I've shown to you. Okay, and then try to memorize them. I mean, when you study, okay, try to memorize them. Okay, I want to mention this one thing, sebab this is something that I learned very recently. You know the apparatus, this one, the list of apparatus and material. Okay, so the list of apparatus and materials, I learned very recently that number one, whatever that they give you, you must write. Okay, so I would always start with, okay, so how I would write this, I would write apparatus, okay, thistle, funnel, what's the second one? Oh, manometer, okay, sorry. Manometer. Now, according to a few people that I've spoken to, actually the apparatus, if you cannot list out everything, is totally fine. Okay, what they are looking for is the original ones they give plus three, okay, three extra things that are useful in this one. Okay, so if I remember correctly from just now, meter rule, okay, measuring cylinder, oh, rubber sheet. Okay, so this is the marking rule. The marking rule is you must put in all the apparatus that is given in the question. Okay, plus another three extra apparatus, at least three lah. If you can list out everything, good. Okay, if you can list out everything, good. Okay, but if you can't remember everything, which is something that always happens to everyone, okay, even me, okay, so you need to put at least three more. Just tambah another tiga apparatus that is useful in the experiment. Don't lah put stopwatch. Okay, stopwatch got nothing to do with this experiment. You must put three apparatus that has to do with the experiment in order for you to get the 1 mark. So there is a little bit of kelonggaran there already lah. Okay, you have to put in the senarai radas yang ada dalam soalan. Just tambah tiga saja, at least three. If you can put in the full list, even better. Okay, but if you can't, at least three, kamu akan dapat 1 markah. Okay, so that's good news. Okay, that's good news for a lot of us, especially those yang selalu lupa the apparatus. Okay, so yeah, so take note of that. That's the slight change that we have for the marking lah. Okay, of course, the arrangement of apparatus ini memang tiada inilah. You have to draw fully. Okay, lukis penuh with label. Okay, no label, 0 marks. Okay, definitely. This is like bio and chemistry. You must label everything. Okay, everything must be labeled. I mean, just label ni mah. Okay, so can. So, so yeah. Okay, that's the experiment for apa tu? For chapter 3. Okay, that I want to focus on for today. Okay, I think I just want to end this by showing you the type of situation for density and depth. So just now what we saw was density and pressure. Just now the situation we saw, this one, okay, is for depth and pressure. Okay, semakin dalam, semakin besar tekanan. That's why the bubble is small. Okay, but I want to show you situations yang melibatkan density and pressure. The bigger the density, the bigger the pressure. How you know is density? Okay, so this is one example. Diagram 1.1 shows a diving in swimming pool, shows the same diver in sea water, swimming pool and sea water. Okay, he dives at the same depth. Okay, so this is our constant variable, but he feels ear sick when he's diving in sea water. Why does he feel ear sick when diving in sea water? Because pressure is higher. Why is the pressure higher? Because the density is higher. So this is an example of density versus pressure. Okay, the MV is density, the RV is pressure, which is operationally defined. Okay, operationally defined as uh, the difference in height in millimeter. Another example would be this. This is a past year trial question, I think. Okay, conditions of identical metal boxes. So you have a metal box over here. One is in river water. So this shark over here is river water, and this shark over here is in sea water. And think about the sea water is more chemic than the river water. Okay, the metal box tied to the small shark is more crumpled. Okay, and then of course diesel funnel and measuring cylinder. This is this one. Okay. Is there any more? Oh, okay, no. So please remember this lah. The operational definition, pressure in liquid is represented by the difference in height in manometer. Okay, so yes. Okay, so I think that's all for today that I want to cover with you. I hope that this has been helpful for you. Let's just do a short recap. Number one is buoyant force. We talked about hot air balloon and certain aspects of buoyant force. Okay, Archimedes principle. Secondly, we talked about Bernoulli's principle. Okay, we also talked about the question to do with the Plimsoll line. Okay, and then of course we talked about section C question about pressure in liquid and about the dam. Okay, don't forget if even if you circle 3 out of 4, you still choose that one and you list out the same one in that particular alat. Okay, and then finally the experiment to do with pressure and liquid. Okay, so pressure in liquids. Okay, so 2 experiments. One is MV is depth, and the second one is that MV is density. Okay, so I hope this has been helpful. In our next class, we will talk about another subtopic, another chapter, okay, most likely another chapter. And once again, I highly encourage you, if you have not done the analysis of the kertas-kertas percubaan negeri, please do the analysis. Okay, when you do the analysis, you will see which topics are hotter this year. Okay, and which topics that you can maybe relax a little bit in those topics. Okay.